Okay, welcome everyone. I'm James, CEO and co-founder of Neuron, and I'm going to be talking to you a little bit about how we're powering machine-to-machine commerce. So my background is in engineering. I've been in engineering around about 16 years, in the drone industry particularly. It seems as drones are a big thing in DePIN apparently, so I'm another one in the team. But I've also worked in mission-critical systems, so looking at verification and assurance of these systems. So really, okay, this isn't a case of just build it and hope it works. We need to make sure it works. I've also worked in banking and consultancy. I've run my own consultancy in drones, consulting with people like the Civil Aviation Authority and also with PwC as a subject matter expert. And I've been in Web3 since 2017. So I kind of rode up the Bitcoin wave in 2017. I'm sure some of you will understand that. And I kind of realized that there's an opportunity here with DePIN, or what back then was just decentralized networks, and connecting those into robotics. Neuron itself, we've been established since 2019, end of 2019, so just over 5 years. We're based in London in the UK. We've got a team of about 12, around about 6 full-time and 6 part-time there. Really what we're trying to do is build a vision where ultimately today humans are the customers. And we believe within the next 5 years, machines and AI systems will be the customers. Our focus at the moment is on premium data services, so buying premium data services from machines. And we're backed by Outlier Ventures, Ecosonic, and the UK government in UK research and innovation. So at the moment, we're seeing a lot of supply side within DePIN. We see millions of devices all around the world deployed, but we're not seeing the customers come in the quantities that we'd hope. We're seeing some projects doing fantastically well. Tom went and talked about one in GeoDNet earlier, who are making waves in the GNSS space, which I also have a bit of experience in. But what we're not seeing is widespread adoption. And why is that? Well, ultimately, access to DePIN networks is very difficult. It's also very inefficient. What we have is a situation where you're having to quite often go to web forms and contact the founders to actually access the data. Purchase API keys, use credit cards, sign contracts. These are things that robots and AI agents aren't able to do. A lot of these networks also pass data into centralized clouds. And centralized clouds are great for storing data, but for real-time data, they have a few drawbacks, one of which is around latency, another is availability of these systems, and also around cost. So what we've developed is an edge network that enables any machine to access any other machine's data. And what that enables is AI agents and applications to access data in a streamlined fashion and get high-performance data from those machines. So that enables rapid data transfer. So you're doing peer-to-peer, which is what blockchain is all about. High-integrity data coming from those. And also increased reliability from these systems. And so this access can be at the machine level or at the cloud level. Now, the rise of AI and robotics is really creating a demand at the moment for high-quality data and automation of access. Machines and AI systems need high-quality, high-performance, and trusted data. And they will seek that out. AI systems will always seek that out. Premium data service is about a $3.5 trillion market. So this isn't a small market we're talking about here. And then when you look at the global market for services, which is ultimately going to be replaced, if you believe Elon Musk, by machines and AI systems, we're talking about a huge market of online digital services. So our system is an infrastructure, and what it enables is machines to buy from machines. And that's secured by a validator network. And the validator network basically ensures trust between the two parties. You've got machines on one side as the suppliers, and you've got machines on the right-hand side, which are the customers. And they can be AI systems and applications, robotic applications in the future. We have a virtual wire that connects customers, buyers, and sellers together, and that enables rapid data transfer in a peer-to-peer or machine-to-machine or computer-to-computer fashion, and token payments in the other direction. We have a set of explorers for discovery of machines, and we have a set of validators for resolving any disputes that might happen. Here's an image of our Explorer. What the Explorer is really there to do is to take all of the machines off all of the different networks and aggregate them into a registry, a directory that other machines can pull off. It's an open source Explorer. Anyone can run one if they want to. They can set up their own business models around them, charge for the APIs that they produce. So this is really just a decentralized directory. And this decentralized directory holds information about those machines. So how do I find it? What's the price of the service? What kind of service is it that it's providing? And what accounts do actually communicate through? Other machines can then access those APIs to then find out, okay, what machines are in my area. If I want to access, for example, a weather sensor in a particular location, they can use an API to find those weather sensors. So our business model is around the validator network. So how do we actually make money? Well, we basically charge a commission, and those validators are there to ensure trust between the two parties. So we take a small commission, and then validators earn that commission essentially for voting in the case that there's a dispute between the parties. They also enforce reputation, which is an important thing. If you've got a decentralized world, how does a machine know whether it should be buying from another machine or not? As humans, we rely on reputation, and machines and AI agents will do exactly the same. So we've already tackled 3 industries here. Flight tracking within the transportation industry. We've now just adopted weather within the environmental sector, and we've also looked at mobile data within the communication sector. But this is broad. This is across services, whether that's smart homes to financial markets and even education. All of these markets rely on premium data. Now, to set up a node, it's fairly straightforward. What you've got is you need to define your service. So are you providing a weather service? Are you providing a GNSS service? You then need to install your environment variables, which are basically just your public address and your private key. There's a few others in there as well. But really, these systems are going to be reliant on an address to go and transact with each other. You install your machines, install this on your machines, and then run the executable. It's quite straightforward. It takes less than a day to do. It's easy to set up. And as a customer then, if I want to go and access this data, it literally a matter of milliseconds to access it. Run the executable, and now I've got data streaming straight into my computer in a peer-to-peer fashion. And this was, I think, in one of the machines was in London, the other was in New York. So you can see within literally 0.1 of a second, the data was now coming through to my computer. And this is one of the applications that our customers are using this for. So on the left here, you'll see Land's End Airport. So Land's End Airport have Neuron installed in their air traffic control tower. So they're using this to see aircraft which are moving around the sky. On the right-hand side, you'll see one of the drone customers that are using Neuron to consume data from the Jet Vision network, flight tracking network. So you can see the view that they have on their laptop, and you can then see what's happening in the sky. University of Southampton, or Southampton UAV, were working with Wind Racers, a drone delivery company, and they were testing detect and avoid systems. So these are aircraft being flown at each other and using Neuron data feeds to avoid one another. And we're now doing some really cool stuff in the AI agent world now. I believe this is the first time this has ever been done. Of an AI agent buying data from a machine, consuming it, connecting it, authenticating, and then providing answers. So what we did is we've got, normally you have MCP servers connected to MCP clients. Those MCP servers are usually local. They're connected to local data. They're usually on your own computer. What we've done is we've actually put the MCP server on the data source. So you can have a data source in New York. You have that attached to an MCP server. It has a series of access controls to it, so you can decide what kind of data you want to give access to. And that data is retained with the owner. We're not trying to get you to pull that off your server and put it somewhere else. Keep it where it is already, install a plugin, and now that's accessible to any other machine or AI agent around the world. What the Neuron network does is it enables customers to discover, connect, pay, and have that payment protected. Each party has an EVM address, so they're able to discover and connect and pay one another. And no API key, credit card, or contract is needed within that process. And now I'll show you a quick demo. So here you'll see on the left-hand side the MCP chat. So this is just the interface that a user would use. In the middle, you'll see the buyer nodes. So these are attached to the MCP client. And on the right-hand side, you'll see the MCP servers, which are in New York, attached to the data. And you can ask it questions, and it will ask you, it'll tell you things like, okay, are you happy to pay for that data? You can respond yes, and then it will literally go to the other server, the MCP server, download the data from the supplier, and transfer that to your machine, and then answer the questions for you. So we did that with the SkyX network. I believe Frank's here today. I can't see him now, but if you want to speak to SkyX, they're here today. And with Roam. So SkyX does weather data, and Roam is looking at mobile network coverage data. But this essentially enables you to talk to these data sets as if they were literally on your computer. They're around the world, maximum latency usually around about 200 milliseconds if it's halfway around the world. But they're literally traveled at the speed of light, so as fast as the internet cables will allow you to. And we've done something quite cool with Elisa OS. So Elisa doesn't normally support MCP, so our CTO actually managed to get it working with MCP, which is, I think, in its own right a first. I don't think that's been done before either. So we integrated MCP with Elisa OS. And we then did some chat. Excuse the prompting. These are engineers prompting the system, not someone actually in a business mindset. But it shows the functionality of people actually talking to an AI agent and trying to go and find information. So we got it working in Lisa OS. So we hope to be able to launch that publicly in the next few weeks. And why would a DePIN do this? Why don't they just do it themselves? Why don't they just give access to their data themselves? Well, they could do, but they ultimately want to get to market faster, cheaper, and not have to do everything by themselves. There's a reason why things are done by organizations in a distributed way. And Neuron enables you to do things 20 times faster, 20 times cheaper, and access a much broader market. If a customer has to do an integration for every single data set, that can be very time-consuming for AI agents to do this. So what we do is one integration for a customer enables universal access across all of the different data sets. So our go-to-market is really around scaling the supply side and demand side simultaneously here. So we're integrating with some DePIN networks, and we're trying to focus on those with edge compatibility rather than cloud-based integrations. But we're doing both at the moment. When we're going to be integrating the leading AI agent platforms, so the Elisa OSs, LangChains, Virtuals, and in the Hedera ecosystem, we've just been voted into the DAO for OpenConvAI, which is the up-and-coming multi-agent framework within the Hedera ecosystem. We've also got a very good relationship with all the drone delivery companies around the world. So Wing, we're actually in a project with them at the moment, working with them. Zipline, one of our guys actually still works for them. Manor live just over the pond from us in Ireland. You can tell we're from London. And Amazon, we've got very, very strong links to as well. So that first flight tracking use case you saw at the beginning, we did quite well. We launched our testnet, and we ended up doing about 40 million transactions through the network in the last 12 months while we were on testnet. And that led to about 650K of sales through the network. And we've done about 2.7 million of government projects using the network. Government are really interested in this. This is cutting edge technology. This isn't something that's been done before. They're very, very interested. UKRI Research and Innovation Labs have been backing us very, very well. And we're integrated into soon to be 3 airports. We're already integrated into 1, but 2 more are now coming. They like telling their friends about us, so it's going to spread quite rapidly, we feel. And our customers are really around airports, drone operators, and traffic management systems. So that was with the first one, but we're now branched out into other use cases. So we have flight tracking data. We've now got high fidelity weather data that's brought into the system, mobile network data, and we've just integrated multi-agent platforms with OpenConvAI and Elisa OS. So what other solutions are out there for this? Well, you've got a few solutions. They tend to come into two groups. You've got on-chain solutions. Let's push all of the data on-chain and then consume the data from the chain. The problem with that is it's not very efficient. Blockchains aren't very efficient things. They're also relinquish some control from the data owner. You're having to put your data on chain. And a lot of companies don't like the idea of that. Similarly, cloud systems, they're a bit more efficient. Certainly, they're not as efficient as connecting directly to the data, but they're more efficient than the blockchain. But then you're relinquishing all of your control away. You're having to basically trust that third party with your data. They could be scraping it, or they might lose it, or there might be a data breach or anything. Edge solutions are the only ones that provide high efficiency and full ownership control, which are really important for not just Web3 companies, but also Web2 companies who are very precious about their data. So we talked a lot about data. So the short term is really what, from a big vision perspective, we're trying to solve the perception problem. How do AI agents and machines perceive the world around us? So we're trying to enable AI agents to perceive the world. In the medium term, they need to then comprehend the world. Once you've got the perception, you need to comprehend it. And this is where agent-to-agent systems start coming in. Ultimately, one agent can do one thing, but if you have a team of agents, they can comprehend the world a lot better than a single agent. Longer term then, once you can comprehend the world, you can take action in the world. And this is where you can start integrating robots. And so when we start seeing the pathway of where this project is going, we perceive the world, we comprehend it, and then we take action through robots. And I think that pretty much sums up today's talk. Thanks very much for listening. Hopefully you enjoyed it. And if you've got any questions, I'd love to take them from you.
Thank you very much.